Hello everyone, a little tutorial in French on how Darknet ROS can work on a Mac in a Docker. There are plenty of little technical tips. First of all, we need to set up a local network, here it's called streaming, in which the TurtleBot and the Mac are located. The Mac's address, you can see it, 192.168.1.2. This address will be used later to configure the ROS master's environment variable. So here, I'm trying to see if I can ping the TurtleBot from here, and you can see that it works. So I can indeed see my TurtleBot from my Mac. Okay. So now we will try to see how the image is made. Docker. So first, the version I have. You can see that it's 18.5 as the drive, and I have already pre-installed the images because it takes a little time. You can see that it's a Connect Desktop Full Xenial as a base with some additional installations. So in particular, I added the tools, UpTutors, and CWJet, which are essential later to download the YOLO weights. Here, repositories to retrieve keys. So ROS. Dep update gives a small error during execution, a warning, because we are executing as root here, so it still works. You then see the installation setup of the catkin and then the download via the git clone recursive of Darknet. The recursive is essential because we simultaneously retrieve a version of Darknet that will be compiled in the last command the catkin make with. The release bit type. This command is done beforehand. On my Mac, it takes about a good dozen attempts to fit the tool to have the display in the container. Now, I need to add the MAC address via xhost. So here, there's an initial failure, simply because I forgot to launch Quark, so I launch Quark. And then I redo the operation. And you see that it opens an external terminal for me, so it seems to be working. So I added the Mac's IP address as a possible client. And to my server, I haven't written here, but you need to enable incoming connections very, well, in Quark's preferences to be able to display rejected connections. So now I will be able to connect via SSH around the box. So my login is Christopher on this machine. Then I connect and check the environment variables related to the OS. So the main environment variable, I positioned it just because via the router there was an IP change. So the ronsmaster.ui needs to be changed here directly to input my new address, which is 192.111.68.101. and no longer 3. So once I have exported the ronsmaster.ui variable, I can start my Docker with a few small commands, specifically display, and some commands related to listening. You need to publish port 11311, since that's the port where the Orange master will operate, so it needs to be published, and then I start here. The container. You see that I immediately go on the route, and it turns out that on the container, the ROS master URI, since it's the one that will host the roscore, is set to localhost with the correct setup. So the display is as it should be, and in principle I will be able to display applications directly in the container on my screen. So I start the roscore. It seems to be working, and then we'll see that the rows out and the same rows out have been installed. I'll bring up the topic that lists. There you go. So rows out and rows out.gg. And I will do the same by setting it up on the TurtleBot. There you go. Then it sends the same ones. And the rosnode sends the same ones. So the TurtleBot is able to communicate well with ROS on the Mac. So I start here. The TurtleBot, so here this is just to show you what you can do. You need to launch it directly on the TurtleBot, of course not on the Mac. So here it starts. We see that it launches a whole set of services that publish the TurtleBot's information. And in particular, what interests us is being able to retrieve what is needed to control the TurtleBot. And so we see all the nodes that have been added. After this command, we see that the TurtleBot starts moving, and the art oil you saw on the side, there is a small official Raspberry camera that will allow you to capture the video. So here's a small test on the side. I'm going a bit fast. It's the jstest command. So here I use the Logitech F710 wireless. And so I will show you how the setting, so it happens via teleop twist joy. So there are config files, and I made a special one for it. So from there, I reverse the axis to be able to accelerate by pressing up the controller buttons, and I remap the buttons. The buttons A and B to move the robot forward in turbo mode. Well, it doesn't necessarily have efficiency on the TurtleBot, but it's quite necessary. Alright, so just a little config tweak to show you that in the TJoy. I don't know. I specified the right joystick. Let's see, there you go. The right joystick is indeed the SL110, and it's on the GSVR ports. Okay, so we saw that the joystick was working. And now, to control the TurtleBot3 from the joystick, you need to launch via ROS launch, the script, and the launch in the TDOP twist security. So here we go. I didn't include a video here, but the TurtleBot is controlled via the joystick. I showed you earlier. Next, a quick camera launch. So we quickly saw it is done via TurtleBot 3PI camera, the script. And so they publish this Raspicam node. So we will see it here. Here's the Raspicam node. There are also diagnostics that create two nodes. We will see later on in the overall graph of the nodes that have been created and their relationships. So just a quick Eurostopic list. And it allows me to see that the camera publishes on compressed image. So it's Jpeg that is sent visually over the network. And just to retrieve a little bit of information from the camera, I will do a quick post-optic echo on the camera info. So it would allow me to see the camera's resolution. So we see here it's a 644/80. So it's not great. I'm not going to select, I said, the default resolution, and I will note the percentage of the resolution. So you shouldn't move with that. So a little operation, we're going to launch this on TurtleBot. We'll try to retrieve the camera directly on Mac. So here I'm calling RQT, image view. And we see that by setting the right topic, so it's good. Roth, pick an order, compressed image. I managed to retrieve what the TurtleBot's camera sees. I imagine that this script here retrieves all of the published topics that are of the image type, and we can broadcast whichever one we want, either compressed or uncompressed. Here there's a little demo. I'm running the Raspberry Pi. I have the controller, you can see via the joystick we configured earlier. Okay, so here everything is working fine, but we saw that the display isn't working because I specified the display environment variable on the machine. Now, a little subtlety, we're going to run a Darknet in the background. But Darknet wants an uncompressed image. So unfortunately, we saw that the camera is better at compressing. So we're forced to republish the topic. So as you can see through republish, I tried it twice because, well, it just doesn't work. So we use republish, meaning in Raspicam node, the image is compressed, and we republish it as raw out. So camera image raw. That's actually the topic that Darknet expects by default. So I just retrieved the configuration to see which topic it was expecting. And then I selected it as the output for republish. Now, let's just take a quick look at what the graph looks like. So you can see that my earlier attempt with republish is still there, even though there was a crash. Actually, the node is dead. So we're going to do a quick cleanup. So vsnode cleanup to remove the faulty node. It asks me if I really want to delete it. Yes, I confirm the deletion. And so normally I should update my graph. Here, host, there's a body. There you go, we update. And there you have it, it's gone. So I've published. For now, I haven't done anything with it yet since I haven't started Darknet. Now is when we're going to run a Darknet. And we'll see that by default, it launches a small YOLO. You can see the convolutional layers and the values. Just a heads up, I'm running this on a Mac. A quick technical note. As far as I know, NVIDIA Docker hasn't been ported to Mac. So I'm running this little YOLO on the poor CPU of my 2013 Mac. So it's struggling along at just under 1 frame per second. You should know that at the same time it's also capturing the video from the screen. So you can see that it's working. Well, it works in the sense that Darknet has successfully retrieved the decompressed image that was just republished and published a detection image. Here, this is another experiment where there's a small app. I was a bit lazy to program it myself. I found an app online that lets me interact with the tablet directly via integrated ROS. Still using the tablet, I connect it to my local Wi-Fi network. I enter the address of the ROS master on the correct port and I connect. And then there's a specification to make, which is the image you want to display in the center. What I'm going to put here, it requires a compressed image. So I'll set it to the camera output. By default, remember, it's Rusticam in compressed image mode. That's what I'm tapping right now. You could set it to a Darknet type, but that's uncompressed. So you would need to, I'm not going to try it, but typically I think you would republish it in compressed format, and then you could retrieve it directly afterwards the other way around. You can see that I just displayed a configuration in the camera output, which is indeed the same as the one that was on the Mac. I'm showing you exactly through my phone now. What's nice about this app is that there's a little control button, and since I'm connected to the roscore, I'll actually be able to control the robot. This application lets you control the robot directly with your finger and almost by sight on the tablet. There you go. That's everything I wanted to show you. By the way, this is one of my first demos on ROS and Docker. I have my list in there. It was a way to play around a bit and afterwards to develop some recognition features. All right, bye. See you next time.